I'm Gustavo.
I'm Jorge Abdo, and we're going to be explaining the part 1 of the project. So today I'm going to be explaining problem 6 from part 1. So it's asking us to find the probability of A and B, and this is the formula we're going to be using. It's P of A, given A, to find B, equals probability of A and B, divided by probability of B. So in the problem it tells us the probability of B. Probability of B equals 1/5. And it also tells us that the probability of A given B equals 3/8. So now what we're going to do is just implement it in the formula and solve for the missing value. So we put 3/8 equals x. We put the x because we're trying to find this value, and then the probability of B is 1/5. So now it's just algebra. You pass this since it's dividing, multiplying, and you insert this in the calculator, and the answer will be 3/40. And this is the probability of A and B. I'm going to be explaining part B of the same problem. So it gives us the probability of A, which is 5/6, and it gives us also the probability of A and B, and that's 1/8. So we're going to be using the same formula since before, just changing some values because they give us different information. So now it's probability of B given A equals probability of A and B divided by probability of A. So we just insert the values. So we're trying to find the probability of B given A, and it gives us the 1/8, which is the probability of A and B, and we just divide that by the probability of A, which is 5/6. So we just put this in the calculator, and it equals 3/20, and that is the answer for probability of B given A.
Explaining number 21 from part 1. We are randomly selecting a card from a standard deck, which is 52 cards, and we need to find the probability. It is a black or a king. In this case, for the OR, this is a equation. It is probability of A plus the probability of B minus the probability of A and B. So we just simply plot the numbers. We know that for P, probability of A is 26/52. Why 26/52? It is a black. We know they are 26 blacks over the total of 52 cards, plus the probability of B, which is a king. For a king, we know it's 4 over the total of 52 cards, minus the probability of these two multiplying. So we know it is 26/52 times the multiplication of B, which is 4/52. Now, having these problems multiplied, we know it is a total of 15/26 minus these values. This sign is very important, over the 1/26, and these two give us a total of 14/26, which simplified, it is 7/13, and this is the final answer.
I'm going to be explaining problem 1 from part 2. We toss a fair coin 3 times and register the amount of tails obtained. If x is the discrete random variable registered, the amount of tails obtained are. So this is letter B, the probability distribution table. So we did this, and we gathered this information from doing the tree diagram. We got these numbers. So letter B is asking us to give you the probability of 2 tails, which in this case will be 3/8, which we got from the tree diagram, which is here. Letter C is asking us to give you the probability of at least 2 tails. And at least in this case means that we need to get 2 tails or more. At least 2 tails. So in this case, we're gonna add up these two numbers, which will be 3/8 plus 1/8, which give us 4/8, which is 1/2. So yeah, there's the problem.
Yeah.
Okay, this is question number 21, and to solve this, we have to integrate. So first, the 2 in here, we're simply going to add an x. Then in here, we're going to add in the exponent a 1, which will become a 3x squared. And the number that is in the exponent, we have to divide it in the constant. So it will become 2x minus 3 over 2x squared. So now, the numbers that are in here, we have to place them in this term and in another one. When we place the 0 in the first term, it will become, everything will become 0, because if you multiply something by 0, it becomes 0. So 0 minus 2 times 1 minus 3 over 2 times negative 1 to the square. This will be negative 2 when you multiply these two constants, and this will become 3 over 2. So at the end, we will have, after subtracting these two things, we will have negative 7 over 2. But since outside of the parentheses there's a subtraction sign that has to multiply all that is inside of the parentheses, we have to multiply this times this, which will make the negative 7 over 2 a positive number. So at the end, the answer, it will be 7 over 2.